Hi everyone, welcome back to my channel. Today we are doing geometric and arithmetic series. But before that, I'm running micro batches for GCSEs for all subjects at just £6 per hour. Only 3 or 4 students, and we can make it 3 as well. Or if you're looking for any class for any subject from year 1 to year 13, that is still A levels, you can just drop us an email at exactacademy@gmail.com to book your free demo. If you want to access the free worksheets, they are available at exactacademy.com. So we are starting with arithmetic sequence. So arithmetic sequence are also called linear sequence. So you might have studied or have heard of this topic, which is quadratic and linear sequences. So arithmetic and linear sequences are exactly the same, and you can calculate the nth term. The nth term of both are same because that's the same thing, having the different name, but the way of calculation can differ. When we'll be doing linear and quadratic sequence, I'll show you the method there, and here I'll be showing you how you can calculate the nth term of an arithmetic sequence because they have a particular formula. That's why. So say for example, our series is 2, 4, 6, 8, 10. You can clearly see that each term is separated by 2. That means when I keep on adding 2, I'll keep on getting my next term. So a constant number is being added. Such type of sequences are called arithmetic sequence. When a constant number is being added is called arithmetic sequence. Now the constant number can be a positive and can be a negative, both. So it's not necessarily that only positive numbers are being added. Maybe -1 you have to keep on adding. So it can be both. Now let's say the first term be A. Here in this case 2, 4, 6, 8, 10, 2 is the first term. So let's say A be the first term and the constant number is R. That means a constant number R is being added. So here you keep on adding 2. So in this case your R is 2. So R is a common difference. So R be the common difference and A be the first term. So I'm just trying to find a generalized formula. We know that what's a common pattern of arithmetic sequence is A be the first term, then the next term would be A plus R. Then the next term you have to add R once again would be A plus 2R. Then the next term would be A plus 3R and so on, because you keep on adding the same constant number to get the next term. You can clearly see if I'll write the first term is A, the second term is A plus R, third term is A plus 2R, fourth term is A plus 3R, and so on. And there is a common thing that you can see. When my term is second, the number written with R or the coefficient of R is 1 less than it. That means if this is 2, this is 1. When the term is 3, the coefficient of R is 2. When the term is 4, the coefficient of R is 3. So similarly, the nth term would be A plus. Now the coefficient of R would be 1 less than the number of term because it's nth term. So it's going to be n minus 1R, or in most of the books you will find in place of R it's actually D that you will find. So A be the first term and D be the common difference. So Tn represents the nth term. It's going to be A plus n minus 1 times D. Let me do one question to get a better clarity of this concept. Let's say there is a sequence which is -1, then it's 4, 9, and so on. And we have to calculate 20th term of this sequence. We do have the formula. So our first term is, if I'll go to the solution, the first term A is -1. Common difference is 4 minus -1, or it would be easier 9 minus 4. This is how you can calculate the common difference. It's going to be 5. That means if I keep on adding 5 and 5, I'll get the next term. So our formula is a plus n minus 1d for t nth. Now for t 20th, I have to replace n with 20, a with -1 and d with 5. So -1 plus n minus 1, which is 20 minus 1 times 5. So -1 plus 19 times 5. So 19 times 5 is 95. So -1 plus 95 will give you 94. And in this way, I can calculate the 20th term is 94. See, for example, they are asking you what will be the nth term. That's it, only the nth term. Obviously, this is a formula to calculate the nth term, but every sequence has its own nth term because the first term and the common difference are different. So for this one, I'll replace a with -1 and d with 5 in the same formula. So t nth would be a is -1 plus n minus 1 times 5. -1 plus 5n minus 5, 5n minus 6. So the nth term of this sequence is 5n minus 6. And the same thing I was talking about, that when we'll be doing the linear and the quadratic sequences, I'll show you a little different method of getting the nth term, but you can opt this one as well to get the answer. Let me do some more questions on the arithmetic sequence, and then I'll show you how you can calculate the sum of n terms of the series. Question 2 says, if the nth term of the series is 64, then find the value of n, and which series? 4, 7, 10. So first of all, let me write a is 4 here. The common difference that you can see is 3. 7 minus 4, 3. 10 minus 7, 3. That means we are constantly adding 3 to get the next term. So D is 3. Now, it says the nth term of the series is 64. That means a plus n minus 1 times d is 64. We just came across about the formula, which is a plus n minus 1 times d, and that is 64. Let me substitute the value of a and d here. So this will be 4 plus n minus 1 times 3, which is 64. Now subtracting is just the basics of linear equations that I'm doing here. So subtract 4 to both the sides. You'll get n minus 1 times 3 equals 60. Now divide both the sides by 3. You'll get n minus 1 times equals 20. And finally, adding 1 to both the sides or transpose 1 onto the right hand side, you'll get n as 21. That means the value of n here is 21. Moving on to the next question. The fifth term of an arithmetic sequence is 0 and 11th term is 30. Find the 31st term of the sequence. See, it's clear that series is not given, so we are not aware of the first term or the common difference. But at least we have an idea that what is fifth term and what is 11th term. So obviously we have to use the formula here. So nth term is a plus n minus 1 times d. Here, at least we know the values of n. We know when n is equals to 5, your value of nth term, that is nth term, is 0. So putting this in a formula, we'll get 0 is equals to a plus n minus 1, 5 minus 1, 4d. Now for the second one, it's given as n is equals to 11 and our 11th term is 30. So Tn is 30. So again, substituting this in the formula, we'll get 30 is equals to a plus 11 minus 1, that is 10 times d. I have two simultaneous equations that I have to solve. It's very simple simultaneous equation. Let me solve by elimination method. So this is a plus 4d 30 is equals to a plus 10d. Now just subtract, subtract, subtract. Minus 30 is equals to minus 60, and finally d is equals to 5. If d is equals to 5, I can substitute this value in either of the equation to get the value of a. I assume you are aware of the simultaneous equations, and if you're not, I have already made a video on it, so I'm just attaching the link in the description box and it will help you. Now substitute d here, and this will give me 0 is equals to a plus 4 times 5, which is 20, so a is negative 20. Now the question is find the 31st term. So T31 is a plus n minus 1, that is 31 minus 1, 30d. A is minus 20 plus 30 times 5. This is 150 minus 20, which is 130. So that's your final answer. See, this question says in 2010, a bookseller sold 200 books. Each year, he sold 5 more books. Calculate the number of books he will sell in 2030. So that means in 2010, he actually sold 200 books. Next year, which is in 2011, he will sell 5 more books, which is 205. Then in 2012, he will sell 5 more books, which is 210, and so on. It doesn't mean that it says every time he's selling 5 more books than the previous year. If it's mentioned that he is selling 5 more books than what he has sold in previous year, the amount of book, that means what extra he has sold, that would be a different case. Here it's mentioned that he is selling 5 more books. That means every time it's just increasing by 5 with a constant number, and clearly it's an arithmetic progression. So they're asking that what he will sell, what will be the number of books that he will sell in 2030. So immediately I'll do 2030 minus 2010, which is 20. So I have to calculate 20th term. Well, no, because if you take an example, I'm saying in 2010 he sold 200 books. So how much he will sell in 2030? So you will say, okay, 3 years, right? So you will be doing a plus n minus 1 times t, that is 200 plus 2 times t. So it will be 210. But he's selling that on 2012. So it's actually, you are counting 2010 as well, right? The first year also. So it's not the total is 30, it will be 31 plus 1 will be added to it. So in 2030, the n value will be 31. So finding 2030, it will be a plus n minus 1 times t. A is clearly the first term, which is 200. N is 31. So 31 minus 1, and d, the common difference is 5. So 200 plus 30 times 5, which is 150. That will give you answer as 350 books. So in 2030, he will sell 350 books. Okay, now let me move on to a formula. Well, hardly you will find that in GCSE, so I'm just going through quickly a simple formula I'm giving you, and I'll give you one question. If they will give you this type of question, they will definitely mention the formula to calculate the sum of n terms of the arithmetic sequence, or like they will ask you to add 2 or 3 terms, not more than that. But even though I'm just going through it, I'm discussing about sum of n terms of an arithmetic sequence. And the formula is given as Sn is equals to, that means sum of n terms is n over 2 times 2a plus n minus 1 times d. So take an example. We have a series that is 1, 3, 5, 7, so on. And we have to calculate the sum of 19th terms. Or let's say we have to calculate sum of 20th terms. Anything will work. So the formula is n stands for 20 here. A is the first term, which is 1. 2 times 1 plus n minus 1, which is 19, times d is what? 2. You are adding constantly 2. So this is 10 times 2 plus 38, which is 40. So final answer is 400. So the sum of the starting 20 terms is 400. Sum of 20 terms, that means 1 plus 3 plus 5 plus 7 and so on. We have to add till 20th term, and that sum, the formula is given by this, and by applying that formula we have calculated this question. So now let me move on to the geometric progression. Now see the geometric sequence. A geometric sequence is a sequence in which you have to multiply a constant number every time. It can be a number which is greater than 1, or it can be number lesser than 1, or it can be number between 0 or 1, but a constant number is being multiplied every time. That is your geometric sequence. So let's say our series be 2, then 4, then 8, then 16. You can clearly see, if you want to know, the first thing is, if you are looking at it, it's very easy to know that it's not an arithmetic sequence, because the difference is 2, then difference is 4, then difference is 8. That means there's no constant number that you're adding. Now the second thing is, if we look and try to divide it, so 4 by 2, 8 by 4, 16 by 8, that means previous term divided by the last term, or like the next term divided by the previous term. So 4 over 2 is 2, 8 over 4 is 2, 16 over 8 is 2. That means you're getting a constant number 2, and it's giving you a better idea that if you're multiplying it with 2 every time, you'll get the next term. If it's happening that if constantly a same number is being multiplied, then it's a geometric sequence. So let's say our term, like our sequence is, I'm trying to find a general equation, a general formula to calculate the nth term of the sequence. So first term is, let's say, a. So the next term would be a times r. Then the next would be a times r squared. Then next term would be a times r cubed. Why? Because you are constantly multiplying r to get the next term. So a r squared, and ar cubed, and so on. So first term is a, second term is ar, third term is ar squared, fourth term is ar cubed. You can clearly see that the power of r is 1 less than the number of term. So second term power is 1, third term power is 2, fourth term power is 3. Similarly, if I'll calculate the nth term, it will be ar to the power of n minus 1. 1 less than it. So if the sequence is 2, 4, 8, 16, and you have to calculate the 10th term, then formula says Tn equals ar n minus 1. So T10 will be, so a is the first term, 2, or the common difference is 2, because we are multiplying 2 to every time to get the next term. So times 2, and we are calculating the 10th term, so 10 minus 1. So T10 is equals to 2 times 2 to the power of 9 or 2 to the power of 10. Either you can solve this value or leave it like that. So your answer is 1024. So that's the answer. Now let me do one or two more questions to get a better clarity of the geometric sequence. The question says the first three terms of a geometric sequence is given as x over 3, x minus 3, and 2x over 3 plus 6. These are the first three terms of this geometric sequence. Now the sum of these terms are 21. The sum is basically 21, and we have to calculate the eighth term. This is given so that at least we will be having the exact terms, because these terms are in terms of x only. So sum is given so that we can easily calculate the value of x, and then we can have our sequence. So sum is x over 3 plus x minus 3 plus 2x over 3 plus 6 equals 21. So I have added all the three terms, and this is equals to 21. So let me add the fraction first. So x over 3 plus 2x over 3 will give you just x. Added 2x plus x over 3, it's 3x over 3, which is just x. Here x, we have this x, I'm writing it as it is, and minus 3 plus 6 is plus 3. This is equals to 21. So 2x plus 3 equals 21. Bring it here. We'll get 2x equals 21 minus 3. I get 18. And finally, dividing both the sides by 2, x is 9. Now, let me substitute the value of 9 here in place of x to get our terms. So first term is x over 3. That means 9 over 3. So first term is 3, comma. X minus 3. 9 minus 3 is 6. Next term is 2x over 3. If I substitute 9 here, this will give me 6. 9 times 2, 18, over 3 is 6, and 6 plus 6 is 12. So this is our geometric sequence, and I can easily understand that every time the 2 is being multiplied. See, 3 times 2, 6, 6 times 2, 12. So this is our geometric sequence with the first term being 3 and the common ratio being 2. So we know the nth term is ARN minus 1. We have to calculate the 8th term. So A is 3, R is 2, and N minus 1, so 8 minus 1. 3 times 2 to the power of 8 minus 1 is 7. So 2 to the power of 7 is 128. And 3 times 128 is finally 384. So the 8th term of the sequence is 384. So this was like the basics of geometric and arithmetic sequence. So like if the questions are given, it would be very easy for you to calculate. In the next video, I'll be doing the worksheet on geometric and arithmetic sequence. So that's it for today. Keep revising and best of luck for your GCSEs. Bye.